So the maximum rated collector current of the power BJT, that is a very very important thing, because if the current goes beyond this maximum rated collector current, then the transistor will break down. So this is related to the maximum current that the wires connecting the semiconductor can handle. So maximum rated collector current is the maximum current the wires can handle, or the collector current at which the current gain falls below a minimum specified value. So two ways you can define the maximum rated collector current is the maximum current your device can withstand, or the maximum current at which the HFE starts falling beyond the minimum specified value. So two ways of relating to IC rated is defined. So generally, the maximum current beyond which the transistor will go to breakdown. That is one way of defining maximum rated collector current. The second way is the current at which the current gain starts dropping beyond the minimum specified value. For a transistor, you have minimum value of beta, right? So if the current gain is going to drop below the minimum value of beta, that that current value you fix it as maximum rated collector current. So in BJTs, maximum voltage is limitation is associated with avalanche breakdown. In transistors, we have the reverse bias PN junction diodes, we have this avalanche breakdown. So as you apply very strong electric field across the reverse bias character based junction, you have this breakdown happening. So in common emitter configuration, this breakdown involves transistor gain and the breakdown phenomenon on the PN junction. So this breakdown is very well available from the PN junction diode. So when reverse bias collector junction is there, the majority carriers cannot cross the depletion region because the depletion region width is going to be very very larger. So when you apply very strong voltage across the depletion region, that charge carriers will hit each other, producing an avalanche effect. So this avalanche of electrons will cross the depletion region easily. So here in BJTs also you have one collector based junction is reverse bias, right? So this maximum voltage limitation is associated with the avalanche breakdown in reverse bias junction. So typical character IC versus VC characteristics given in figure. So when the base terminal is open circuited, the breakdown voltage is VCE naught and its value is 130 volt. You can see the graph here. So VCE versus IC. Okay, so you can call this as output characteristics. So output characteristics I am drawing at constant base current. Okay, so base current usually will be in the order of microamperes. So as you increase the base current, you can see that the collector current will increase proportionately. So in conventional BJTs, it will increase and it will become constant. It will not change. But here you see in power BJTs, it is increasing and still increasing. It is not becoming constant. It is increasing and it is still increasing. And you can see the family of curves at 75 microamps, 60 microamps, 45 microamps, 30 microamps, 15 microamps. And when you give zero base current, when the base is not given any voltage, which means at 0 microamps, you can see the voltage at which the current starts increasing is 130 volt. So this is the breakdown voltage. So at the voltage at which even without giving any base current, the collector current is very very minimum. Ideally, it will be zero, but because of minority carriers, you will have very little amount of base current flowing through your device, and abruptly after 130 volt, the collector current will start increasing. So that voltage is called as VCE naught. That voltage is called as VCE naught. So VCE naught value is 130 volt. That is what is given in the previous slide. VCE naught value is 130 volt, the value at which the base current is going to be zero. So when the transistor is biased in active region, the collector current will increase significantly before the breakdown is reached. So when you are going to use the transistor in active region, the collector current will be in the normal range, and even before the breakdown is reached, it will be in the normal range. It will not increase much. It will increase significantly, but it will not reach the maximum rated collector current. So once breakdown has occurred, all the graphs will merge. So once the breakdown has happened, see in this case, once the breakdown has happened, when you still increase, all the graphs will be meeting each other. All the graphs will be meeting each other at a particular point. Okay, the curves will merge at one particular voltage called as VCE sust. So this is the sustained VCE hyphen SS means sustained voltage, and it is the minimum voltage to sustain the transistor in breakdown, and that value is given by 115 volt. So when you increase the base current, you can see that all these graphs will be merging at a particular point. So that value of the voltage is called as VCE sus. It is called as sustained collector emitter voltage, which is required for the transistor to sustain it in breakdown, and that value will be very much less than 130. So 130 is the voltage where you have the breakdown, right? So breakdown is attained when IB is equal to 0. So all the graphs, they will be meeting at 115. Okay, they will be meeting at 115 volt. When operating the BJT at high voltage and high current, another breakdown will occur, and it is called a second breakdown. So when you are going to operate the transistor in power BJT mode, you add the voltage is going to be very high. The current is also going to be very high. So you will have what is called a second breakdown. The first breakdown, it is your because of your avalanche breakdown, because of your reverse bias collector base voltage, right? So when you are going to operate the BJT at this high voltage and current, you can expect one more breakdown called a second breakdown. So this second breakdown will also increase the heat produced in the BJT. The second breakdown is also going to increase the heat produced inside your active region of your